A spinning top wobbles on a table. Faster, faster, then a hand slams down. It stops, dead. Right now, you are standing on a spinning top. It's just too big for you to feel it. At the equator, Earth's surface is moving at almost 1,670 kilometers an hour, faster than most commercial jets. You don't notice because everything around you, the air, the ocean, your own body, is moving at that exact same speed. But what if that motion just stopped? Not slowed down, stopped, instantly. This can't actually happen. Angular momentum doesn't just vanish, and nothing in known physics could halt a planet's spin in a single moment. But asking an impossible question is often the fastest way to see what's quietly holding the possible world together. So let's run the experiment the universe never will. The first second, Earth stops. You don't. Your body is still moving at that same 1,670 kilometers an hour because your body isn't attached to the crust, it's attached to the air and the ground beneath your feet, both of which are decelerating far faster than you are. The result is closer to slamming the brakes on a car going 1,000 miles an hour than anything you've felt in your life. Near the equator, this isn't survivable for anything not bolted down. Trees, buildings, entire cities would be scoured off the surface by wind and debris moving at hypersonic speed. The atmosphere itself is the real problem. Air doesn't stop just because the ground does. The atmosphere keeps its rotational momentum, meaning it would keep moving at roughly that same 1,670 kilometers per hour relative to the now stationary ground beneath it. That's not weather. That's a permanent, planet-circling wind faster than any hurricane or tornado ever recorded, according to atmospheric modeling done by researchers exploring exactly this scenario. The oceans behave the same way. Water, like air, has momentum independent of the crust it sits on. Every ocean on Earth would surge westward, essentially becoming one continuous planet-scale tsunami, reshaping coastlines in hours rather than centuries. Now the slower part. Earth's spin isn't just wind and waves, it's also the reason the planet isn't a perfect sphere. Centrifugal force from the spinning bulges the equator outward. Earth's equatorial radius is about 21 kilometers wider than its polar radius, a shape geophysicists call an oblate spheroid. Remove the spin, and that bulge has no reason to exist anymore. Gravity would slowly pull the whole planet back toward a perfect sphere over many thousands of years. As the equatorial bulge relaxes, ocean water that used to pool there would gradually migrate toward the poles, drowning high-latitude coastlines while land near the equator emerges from the retreating sea. Then there's the day itself. Right now, a day is 24 hours because Earth spins independently of its yearly orbit around the Sun. Stop the spin, and the planet is still orbiting the Sun, just without turning on its own axis. That means one side of Earth would face the Sun continuously for roughly half the year, while the other side sat in total darkness for the same stretch. A single day would become one full trip around the Sun, about 365 days of daylight on one side, followed by 365 days of night on the other. The temperature swings this creates are extreme. The sunlit side would bake for months without relief, potentially climbing past 100 degrees Celsius in exposed regions, based on climate simulations of tidally locked planets. The dark side would plunge toward temperatures cold enough to freeze carbon dioxide out of the air, similar to conditions already observed on the permanently shadowed side of Mercury. Weather patterns wouldn't just get more extreme, they'd fundamentally change shape. The Coriolis effect, the force that curves hurricanes, trade winds, and ocean currents, exists only because Earth is rotating. No spin means no Coriolis effect. Storm systems that currently spiral would instead move in straight lines, driven purely by temperature differences between the scorched day side and the frozen night side. Meteorologists studying non-rotating planetary models describe this as one dominant, continuous storm system circling the border between light and dark, rather than the many separate rotating storms we're used to. There's also the question of what's happening far beneath your feet. Earth's magnetic field isn't generated at the surface, It comes from the churning of liquid iron in the outer core, roughly 3,000 kilometers down. That churning is partly driven by Earth's rotation through a process called the geodynamo. If the surface stopped, the core wouldn't necessarily stop with it. The two aren't rigidly connected, and the outer core could keep spinning on its own for a long time. But over millions of years, without the same rotational stirring, many geophysicists expect the dynamo to weaken, and with it, the magnetic field that currently shields the planet from solar radiation. A weaker magnetic field means more charged particles from the Sun reaching the surface, similar to what's believed to have stripped much of Mars's atmosphere over billions of years. So the same planet that once looked so stable starts losing its atmosphere the way Mars did, just for a different underlying reason. There's one more strange side effect, and it's the quietest one. Gravity itself would feel slightly different. Right now, the spin of the Earth creates a small outward centrifugal force at the equator, which slightly reduces the pull you feel there. That's why you weigh marginally less at the equator than you do at the poles, even on today's spinning Earth. Stop the spin, and that centrifugal cancellation disappears. Gravity at the equator would increase by about 0.5%, a tiny number, but a real one, and a reminder of how many small physical bargains rotation quietly makes on your behalf. The spinning top on the table stops, and it just falls over. It has no other option because a spinning object resists toppling only as long as it keeps spinning. Earth is no different. Its spin isn't just where your sunrise comes from. It's the wind staying calm, the oceans staying where you left them, the sky staying blue instead of freezing solid, the ground beneath you weighing exactly what you expect it to. None of that is fixed by nature. It's on loan from motion that started 4.5 billion years ago and has never once been asked to stop. You'll never feel the Earth spinning. That was always the point. It was never something happening to you. It was the thing keeping everything else from happening all at once.